Everything around you is interactive. You can touch, manipulate every object you have using buttons, sliders, and many more. In React Native, we use touch to declare gestures, and it is crucial to know how to use them wisely. In today's episode of How to Animate It, let's learn about the basics of gestures. A very important concept for React Native gestures is called a responder. The way it works is simple. Imagine that your application has one guy in charge of handling gestures. Whenever you press or move something, you need to ask him the right to proceed with the gesture. Another rule is that only one gesture at a time can get his attention. In our application, we'll call this guy the gesture responder, and fortunately, we have an easy way to talk to him. If the following button, for example, wants to be touchable, it needs to let the gesture responder know that if a user touches it, no matter what other movement they do, this button only should be pressed. In other words, whenever you interact with an element or a view in your app, you need to let the gesture responder know which element should become interactive and how. This layer is usually abstracted for you since we use components that have all the logic we need for them to work: button, touchables, and pressable. What might be new to you this time is that you will be in charge of telling the gesture responder when and how you want it to make a view interactive. Let's see how it looks like. As I said, there is a simple way for you to contact the gesture responder. If you have already heard about pan responders, let me tell you that there's an even simpler way of doing it. And by the way, if you haven't heard of it, don't worry, I'll cover it in the next episode. Every React Native view can become interactive the way you want it to be. All you need is to let the gesture responder know how it should deal with any gesture happening inside that view. To understand how it works, we need to look at what is a gesture. It always starts with a touch somewhere on the screen. Then you move it around and you eventually release the touch. These three steps are what define any gesture: a start event, a series of move events, and a final one, the release event. Every view can keep track of this, which means that each view can ask the gesture responder to act in a certain way when interacted with. To do so, there's a bunch of properties every view component comes with. The first two, onStart and onMoveShouldSetResponder, define if a view should be talking to the responder and then become interactive. If these properties return true, then when touching this view, we'll get all the touch events within it. Now, these two other props aren't usually useful. They're just functions called whenever a view has been granted or rejected by the responder, but just so you know, they exist. What you really want to know about is onResponder move and release. When a user's touch is moving on the screen, every move event will be fired through onResponder move. When it's over, it's onResponder release. Now picture this. If you want to move an image around and when you stop touching the screen, it brings this image back in the middle, you could do so using these callbacks. Calling onResponder move when the image is moved, then animate it back to the center when onResponder release is called. Alright, you know all the theory, it's time for practice. Here's what I want us to make today. First, I want to move a cursor around. Just a small circle that will follow my touch. Then, I want to take this cursor back to its middle position when I release the touch. Now for this, I will need two things: a view that will listen to my gesture, and another one to show the cursor. Because the gesture will happen on both the X and Y axis, we'll create an XY animated value to store the current touch position. Now this is something I haven't talked much about yet. The idea is that when we'll move the touch around the screen, it should update this XY animated value. When the value is updated, it should also be reflected in the cursor view position. Also, before we continue, I want to say that if you don't get this the first time, it's normal. The way we handle gestures follows a method that might be new to you, but the good thing is that it is often the same pattern we put in place. Don't hesitate to come back to this video to make sure it's clear on your mind. Alright, back to the example. We have all the components we need to get started. What we'll do first is to set the parent view as the one responsible for the touch events. If we set onStart should set responder to true, we're letting our gesture responder guy know that this view should get all the move events happening on this part of the screen. Even if I move my hand on the cursor view, which is a child of the parent, it shouldn't be affected since only the parent asked to be the touch responder. Remember, we need to ask for it, otherwise it won't be interactive by default. So after asking for the view to become the touch responder on start events, we actually need to do something whenever the touch moves. In our case, we want to update our animated value to store the current touch position. If we look at the onResponder move callback event, it contains a few interesting information on the current touch. The ones that are useful for us are location X and Y, which both correspond to our current finger position on both axes and relative to our view component. We'll call setValue on our animated value and set the new position using the even values. Now that we listen to the touch event when it moves, that we have the current touch position, we can move the cursor view around based on the animated value. To do so, you know the drill, we turn it into an animated view and set the left property to the X cursor position and top to Y. At this point, you might have noticed something, which is that the cursor won't be exactly positioned where I touch, because if I set the view to be at the exact same touch position, it will draw the circle below the touch. We can center it by subtracting half of the circle size to the touch position on both axes. Remember that you cannot manipulate animated values like this, but you need to use animated operator methods that do exactly what you think they will. In this case, we need to subtract the cursor half side size constant, so let's use animated.subtract. Great, we can now add the last part, which is bringing the cursor back to its middle position after we release our touch. We can use onResponder release for that, which will call a spring animation on the animated value. The X and Y values correspond to the middle point of the screen minus half the cursor side. Remember that this is just an example of what you can do with bare properties on views, but there's a lot more to explore using the other properties from the touch events. You can add all sorts of logic, such as blocking a gesture past a certain point or snapping the values around given thresholds. This is not something you'll learn from a video, you'll need to actually do it to learn, so be brave and give it a shot. Alright, let's wrap this up. There are 3 things to remember today. Here they are. First, a gesture responder in React Native is in charge of gestures and needs to be talked to for an element to become interactive. Every single view can use its properties to tell the responder when and how it should turn interactive. That especially includes any gesture logic through onResponder move, onResponder release, etc. These properties are useful to define side effects based on the gesture, namely when it starts, moves, and ends. Alright, that's it for now. In the next episode, we'll keep learning about gestures following what we've learned today, using a pan responder this time. Remember to subscribe if you don't want to miss it. Thanks for watching, and see you next time.